All right, today we are doing our last lesson on radicals. Tomorrow we will review everything we've done this week and then take a quiz over our operations with radicals. So we will need to be able to simplify them, add them, subtract them. And today we will be learning how to multiply, divide, and rationalize them. So, for our warm-ups, this is what we did yesterday. Adding and subtracting radicals, the first thing we have to do is simplify them. So we need to check to see if these radicals can be simplified. The number out front just stays out in front. It will get multiplied to any other number that comes out front. What can 12 break into? 6 and 2. Which one of those can break down more? It breaks into 3 and 2. So we have a pair of 2's. So we already have a 3 out in front. What's that going to get multiplied by? A 2 that we bring out in front. 3 times 2 is 6. What's left under the radical? The 3 that was alone when we split it up. Next we have to break down the 27. What does 27 break into? 9 and 3. 9 breaks into, what do we have a pair of? 3's. So there's already a 4 out in front. We multiply that by a 3 to get 12. What's under the radical still? A 3. When we go to add them together, what gets added? The coefficients, which in this case are 6 and 12. 6 plus 12. 18. What's under the radical? A 3. The part under the radical does not change. So our final answer is 18 root 3. Questions on that one? All right, on number 2, we have to break down the 125. How did we break it down? 25 times 5. Which of those will break down more? Breaks into 5 times 5. What do we have a pair of? Pair of 5's and a lonely 5. We already had a 5 out in front. It gets multiplied by another 5 to give us 25. What's under the radical still? The lonely 5. Remember, if you need to, once you break a number down, you can cross it off because we don't care about it anymore once we break it down. All right, we have to break down 250. 10 times what? 10 times 25? All right. 25 breaks into 5 and 5. We know we get a pair out of that. Are we going to get another pair out of the 10? No. So do I need to bother breaking it down? Not really. You can, but you're just going to end up multiplying them back together. Was there anything out in front of the radical to multiply to this 5 that's coming out? Nope. So it becomes 5 square root of 10. Are we all okay with that middle piece? All right, and then the last part is just plus 10. That's not changing. Plus 10 is just plus 10. There's no radical to simplify. What here can get combined? Good, Martez. Nothing. It stays that way. None of these radicals match. The 10 back here doesn't even have a radical. So this up here that we rewrote, that's our answer. 25 root 5 minus 5 root 10 plus 10. That's as simple as it gets. There is nothing that we can combine. Questions about it? All right, on number 3, we have to break down the 8. What will it break into? Okay, the 4 breaks into 2 and 2. What do we have a pair of? 2's. Okay, so we already had a 2 out in front. It's going to get multiplied by another 2 to give us 4 square roots of 2. There's still a lonely 2 that didn't have a friend. Minus, we break the 15 down. Can 15 break down? I mean, yes and no. We say yes because it can break into what? 3 and 5, but do we get a pair out of that? No, so is it going to change?
Nope.
No, it stays 2 root 15. Can we combine those? No, why not? Because why? The radicals are not the same. The radicals don't match, so we just leave it 4 root 2 minus 2 root 15. Alright, today we are going to talk about the product and quotient of radicals. Our objective will be to multiply and divide radical expressions. Products of radicals. Multiplying radicals is pretty easy. You multiply the coefficients together. Those are the numbers out in front. You multiply the numbers that are under the radicals together. You leave them under the radical for now. And then we simplify the whole thing. All right. Let's do some examples. All right. Our first few examples are not all that exciting, but they'll get us used to how these rules work. Before we get started on these, it's important to talk about what number is in front of the radical if we don't see a number written there. A 1. Okay, so if it helps you, you can go through and fill that in. If there's not a number right in front of the radical, we know it's a positive 1. Okay, so we can go through and fill that in on all of them if we want to. Now our rules on the previous slide said that we multiply the coefficients, or the numbers out in front, together, and that stays out in front. We multiply numbers that are under the radicals together, and initially they stay under the radicals. So for this first problem, the numbers out in front are 1 and 1. 1 times 1 is 1. Underneath the radical, I would take 3 times 2, and that would give me 6. It says the last step is going to be to simplify. Is the square root of 6 going to simplify? We should know this from yesterday. If we break 6 down, are we going to get pairs out of it?
No.
No, so will it simplify? No, if you can't get pairs, you can't simplify it. So you can either leave it as 1 root 6, or you could just write it as the square root of 6. On number 2, when I multiply my coefficients together, what do I get? 1. The coefficients are 1. Do I need to bother writing it? Not really. If you want to, go for it. When I multiply underneath my radical, what do I get? 18. Okay. So then I have to decide, will the square root of 18 simplify? Yes. What can I break 18 into? Well, you can go back to 3 and 6. That's what we used to get it. And then the 6 breaks into 3 and 2. So what do we have a pair of? I have a pair of 3's, and what's alone?
2.
The 2. So the square root of 18 simplifies to equal what? 3 radical 2. Very good. Or 3 root 2, whichever way you prefer to say it. So squaring something means we multiply it by itself. Do we need to write the 1 out in front of it? No. If you want to, you can, but you don't have to. So what this means is we're taking the square root of 2 times the square root of 2. If we multiply what's under the radical together, what does that give us? 4. The square root of 4. And because we all know all of our perfect square numbers, we know that the square root of 4 is just 2. So our answer comes out to just be 2. Again, squaring something means you're multiplying it by itself. In this case, we're squaring the whole thing in parentheses. So that means we have 3 root 2 times 3 root 2. This is the first time we've had something other than 1 out in front of our radical. So those numbers get multiplied together. 3 times 3 gives us 9. The numbers under the radicals also get multiplied together. That gives us 4. All right, so far we have 9 root 4, but we know the square root of 4 simplifies to be what? 2. What do you think is going to happen between the 9 and the 2? We multiply them. 9 times 2 is 18. So our answer does not involve a radical at all. It's just the number 18. Quotients of radicals. We can't leave radicals in the denominator of a fraction. We have to what's called rationalize all of our answers. Don't forget to have them in simplest form. This should say simplest, not simplify. Simplest form. On these, we are asked to simplify each quotient. I'm going to change number 5 to include a radical in the denominator as well. Otherwise, there would be nothing for us to do. In order to do what we call rationalize a denominator, what that means is to get a radical out of the denominator, we have to multiply the numerator and the denominator by the radical part that's in the bottom. So we're going to multiply the top and the bottom by the square root of 3. To rationalize a denominator, you multiply the top and the bottom by the radical part from the bottom. Okay, so then let's get what our answer would be so far. In the numerator, if we take the square root of 5 times the square root of 3, what will that give us? Not just 15, but the square root of 15 or radical 15. In the denominator, the square root of... In the denominator, we take the square root of 3 times the square root of 3, and what does that give us? The square root of 9. Now you might be thinking, I thought the point was to not have a radical in the denominator anymore. How's the denominator radical going to go away? We simplify it. What's the square root of 9? 3. We should have already learned from previous examples that the square root of 15 cannot simplify. So it just stays the square root of 15. We can break it into 5 times 3. However, that does not give us a pair. So therefore, we are finished. Square root of 15 over 3 is our answer. Okay, we have a fraction under one big radical symbol. But that's okay. What that means, it's the same thing as taking the square root of 5 divided by the square root of 6. So nothing about how we do this problem changes. Even though it looked different in the beginning, these mean the same thing. So we can handle it the same way. So we are going to multiply the numerator and the denominator by our radical from our denominator. Now, hopefully we're getting to a point where we don't have to write out every little step. If we do, it's okay. But hopefully we're getting quicker at seeing what happens here. What's going to happen in my denominator? It's not just the same, it's close. The square root of 36, what is the square root of 36? 6. Okay, so it's 6 without a radical over it now. That was our goal. Not just 30, the square root of 30. No, that would be wrong. Because the square root of 6 times the square root of 6, that gave us a perfect square number. So the 6 in the denominator no longer has a radical. Just like the 3 on the last example doesn't have a radical. So I heard, I believe it was Nikitra say, so that's just the answer. Yes, it is, but we have to check before we decide that for sure if the square root of 30 can be simplified. So when we check that, what does 30 break into? Okay, we can break it into 5 and 6. 6 breaks into 2 and 3. Do we get any pairs out of that? No. So that's how we know it doesn't simplify anymore. We're just going to leave it right there. Number 7, not a whole lot different from what we've been doing. What am I going to do to get the radical out of my denominator, Quentin?
Multiply the bottom radical to the top radical.
And? Close. We have to multiply it to both the top and the bottom. If we do something to the top, we have to do it to the bottom, so that way we're not really changing it. The square root of 2 over the square root of 2 is equivalent to 1. Multiplying something by 1 doesn't change it. That's why we're allowed to do this. What am I going to get in my denominator? We could write it as the square root of 4. What about in the numerator? Not just 6. The square root of 6. Which of those pieces simplifies further?
4 and 6. No, just 4.
Just the 4. What's the square root of 4? 2. Does the square root of 6 simplify? No. A 6 only breaks into what? 2 and 3. Does that give us a pair? Good. We cannot simplify this any further. Last year I had people say, can't you divide 6 by 2? But there's an issue with that. This isn't just a 6. It's a square root of 6. It is not the same thing as just the number 6. So we cannot simplify that anymore. We can't have a radical in the denominator. So on number 8, we are going to multiply both the top and the bottom by, not just 3, radical 3. Does this 6 have a radical part? No. Okay, so when we multiply 6 times the square root of 3, that just gives us 6 root 3. If you take 6 times the square root of 3, it's just 6 root 3. Kind of like 6 times x is just 6x. It's the same idea. In the denominator, the square root of 3 times the square root of 3. The square root of 9. What is the square root of 9? 3. We are not done with this problem, but we will pause here for questions. We're not done with this problem because we have a 6 over 3. Those are just integers. As a fraction, they can get simplified. They're not under a radical. What is 6 divided by 3? 2. So this becomes 2 radical 3. The radical part does not change. If you still wanted a denominator, what would go in it? A 1. Do you need it? No. Sometimes, to help us get through problems quicker, we should look to see if we can simplify it before we start rationalizing. Can the fraction 10 over 8 be simplified?
Yes.
Yes. What does it simplify to? 5 over 4. Are we all okay with that step? Then we're going to split up the radical like we were doing before, where we give it to both the top and the bottom. Instead of writing one big one, we write one over the top, we write one over the bottom. What else can we do to simplify this before we talk about rationalizing? We don't have to multiply on this one. The square root of 4 is 2. So we don't even have to rationalize it. Because now, since we simplified it, there is no longer a radical in our denominator.
So we can do that any on any.
If the problem will simplify. This is the first one we've seen where the fraction would simplify ahead of time. Questions on 9? Yes.
We do the same thing with number 10.
We cannot do the exact same thing with number 10 because there is not a radical in the numerator. We do have an option on number 10. We can either simplify the radical 18 first and rationalize later, or we can rationalize it first and then simplify later. Rationalize first? Okay. If we rationalize first, that means we're multiplying both the top and the bottom by what? The square root of 18. In the numerator, 6 times the square root of 18 is just 6 square root 18. The square root of 18 times the square root of 18. Recognize that pattern. If we multiply two identical square roots together, we just get that number out of it without a square root. Simplify the fraction part first. 6 over 18 simplifies to what?
3.
1/3. Okay, so we can divide both of these by 6. So it simplifies to 1/3. What's still under the radical? 18. But are we done? No. The square root of 18, all on its own, simplifies. What does 18 break into? 9 and 2. 9 breaks into 3 and 3. What do we have a pair of? What's alone? Okay, so instead of having 1 square root 18, what do we have instead? 3 square root 2. What's still in the denominator? 3. Now what simplifies? 3 over 3 simplifies to be 1. So we are just left with 1 square root 2 or just square root of 2.